So up at the top of your graphic organizer, it says quadrilaterals. So what did we decide? What did we decide yesterday we meant when we said we're talking about a quadrilateral? How many sides? 4 sides. So a quadrilateral is a polygon with 4 sides. And then following from what we were just talking about with the opener, what do all the interior angles of a quadrilateral add up to? Triangle is 180, 360. So our interior angles add to 360. So this is going to be true for any quadrilateral. We're going to talk about trapezoids and kites a little later towards the end of the unit, so we'll need this graphic organizer towards the end of the unit. For today, we're just going to go down the middle of the graphic organizer. So we're going to start by talking about parallelograms. So parallelogram, one type of special quadrilateral. So a parallelogram, parallelogram is a quadrilateral with 2 pairs of parallel sides. So on your picture, we're going to add a lot of information to each of these shapes. So I don't know that we can draw all the different pieces that we're going to talk about, but on this one we definitely can draw that our sides are parallel. So our parallelogram, we're going to have this side parallel to that side, and that side parallel to that side. A lot of other things happen when we know we have a parallelogram. Opposite sides are congruent. So these 2 sides are parallel, they are also congruent. These 2 sides are parallel, they are also congruent. So if you wanted to add your congruent marks on there, you could. Opposite sides are parallel and congruent. Opposite angles are congruent. So if we go across the parallelogram, those angles are congruent. The angles on opposite corners of the parallelogram are congruent. Consecutive angles are, thank you, supplementary. Consecutive just means 2 in a row along the side. And supplementary means what? Add to 180. So opposite angles are congruent, consecutive angles are supplementary, and we also know when we have a parallelogram that the diagonals bisect each other. So bisect means what again? Cut in half. So the diagonals cut each other in half. So So all of these things happen when we have a parallelogram. We have two pairs of parallel sides. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. All right, questions on parallelograms? Okay, let's go to the right there and talk about rhombuses. A rhombus is a parallelogram. It shows on our graphic organizer. So everything that's true about a parallelogram is also true about a rhombus. A couple of other things happen with the rhombus. Rhombuses have 4 congruent sides. So if you wanted to add that on your picture, and we usually draw rhombuses that look kind of like a diamond. It doesn't have to be that way, but usually that's how we look at them. So for a rhombus, all of our sides are congruent. So we have a parallelogram with 4 congruent sides. Something else happens with a rhombus. The diagonals are perpendicular. Perpendicular means what? They intersect at 90 degrees. They make a 90-degree angle with each other. And because it's a parallelogram, we know that the diagonals bisect each other. So the rhombus has all the properties of a parallelogram, along with 4 congruent sides, and the diagonals are perpendicular. Something else happens with a rhombus. The diagonals bisect the angles. So if I were to draw a diagonal here on my rhombus, it would split these angles in half. So if we know we have a rhombus, we can figure out lots of stuff, because everything that's true about a parallelogram is true about a rhombus, and the diagonals are perpendicular, and the diagonals bisect the angles. Questions about a rhombus? All right, let's talk about a rectangle. All right, so rectangles. Rectangles are parallelograms. So everything that's true about a parallelogram is true about a rectangle. Rectangles have 4 right angles. So if we add that to our picture of our parallelogram there, of our rectangle, all of these angles would be 90 degrees. Everything that's true about a parallelogram is true about a rectangle, but a rectangle has 4 right angles. Also with a rectangle, the diagonals are congruent. So everything true about a parallelogram is true about a rectangle. Opposite sides parallel, opposite sides congruent. Diagonals bisect each other. Consecutive angles supplementary, opposite angles congruent. And the diagonals are congruent on a rectangle. And we'll talk more about that idea a little later in the chapter as well. So questions about rectangles? Okay. Square. Over to the left on your graphic organizer. So, or sorry, on the bottom of your graphic organizer there. So square is special. What's special about a square, and the graphic organizer shows this. Square is a parallelogram. It is a rectangle. And a rhombus. And another thing that's special about the square, because all these are true, it has 4 right angles. That comes from because it's a rectangle, and 4 congruent sides. So a square has all the properties of a parallelogram, all the properties of a rectangle, all the properties of a rhombus. So part of that is it has 4 right angles, 4 congruent sides, and the diagonals they bisect each other. They are congruent. They bisect the angles. And are perpendicular. So all of these things are true about the diagonals of a square. They bisect each other, they're congruent, they bisect the angles, and they're perpendicular. So if we have a square, we have all kinds of things going on with the diagonals. And we also know that we have 4 right angles, 4 congruent sides. Yes? Diagonals go from, so let me draw a picture here. So if this is our square, diagonal goes from corner to corner. So that would be a diagonal, and that would be a diagonal. Now on a square, they cut each other in half, they're perpendicular, they bisect the angles, they're congruent, all that stuff. The diagonal goes corner to corner. So questions about a square? All right. We have one theorem. So we talked about our properties of special quadrilaterals. We'll get to trapezoids and kites a little later. We're going to talk about one theorem, then I want to do a few examples. What we'll do tomorrow and Friday is So today we're talking about if we know we have these special shapes, what else can we figure out? What we'll talk about tomorrow and Friday is if we know some information about a shape, what kind of shape can we figure out that guarantees us that it is? How do we know when we have a rhombus? How do we know when we have a rectangle? So we're kind of going to go the other direction on block day and Friday. Let's talk about our theorem. So this doesn't have a special name, just it's a theorem that we can use special quadrilaterals to show that it's true. So that's why we're talking about it now. So our theorem says we have 3 or more parallel lines. And these parallel lines cut congruent segments on a transversal. So we have these three or more parallel lines. They're cutting congruent segments on a transversal. If that's true, then they cut congruent segments on any transversal. Let's draw a picture. I think makes a little more sense than the words here. So here are 3 parallel lines, and here's one transversal, and here's another transversal. And we're saying all 3 of these lines are parallel. And we'll label our points. And we're saying that those segments are congruent on that one transversal. Thank you. So we're saying that if line AB parallel to line BC, and that's also parallel to line EF, and AD, segment AD is congruent to segment DE, then we know that segment BC is congruent to segment CF. So we can figure out that these are the same also. So if our parallel line cuts this into equal pieces, it also cuts the other transversal into equal pieces. So that's what our theorem says. So questions there? And we'll show the example. This is not a difficult idea, pretty easy idea. All right, so what I want to do is do a couple of examples that have to do with these special quadrilaterals with this theorem, and then we'll go over our homework. So here is a parallelogram. We're going to draw a parallelogram. And we'll call this our ST. And this is 71 degrees. In our book, they use this little symbol for parallelogram. So when you see that little symbol, that means parallelogram. So we know that RSTU is a parallelogram. We want to find the measure of angle R. So we're looking for this angle. So we have two angles along the same side of a parallelogram. What do we know about, and we call those consecutive angles. What do we know about consecutive angles of a parallelogram? They're supplementary. Opposite angles would be congruent. On the same consecutive angles of two in a row are supplementary. So how do we find the measure of angle R if we know this is 71 degrees? Subtract from 180. Measure of angle R is 180 minus 71. And that gives us, when we do that subtraction, 109 degrees. So we know that's 109 degrees. This angle would be 109 degrees. That angle would be 71 degrees. Any two in a row have to add up to 180. Two across from each other have to be the same. Questions there? All right, let's look at this one. So we'll draw a nice shape here. And we know that these three segments are all parallel. That segment's 5, that segment's 5, that segment's 7, and we call that x. We want to find x. So we have three parallel lines, cuts this segment into equal pieces. What does it do to this segment? We just said on our theorem. Also cuts this segment into equal pieces. So what would x be? X has to be 7. The parallel lines cut this side into equal parts. It also cuts this side into equal parts. So x equals 7. Questions there? Okay, let's look at this shape. So we have this, and we going to tell you some information about this, and we want to figure out what else we can figure out. So I'm going to tell you that this is a parallelogram. So it's a parallelogram, and I've marked these pieces congruent. We want to know what else. What else is it? How else can we name it? How else can we classify it? So what do we think here? It's a square. And what tells us? What tells us that it's a square? How can we figure that out? These two, the opposite angles have to be congruent. So these two angles have to be 90, and two angles in a row on a side have to be supplementary. So these two have to add up to 180. So that means that all four of the angles are 90 degrees. So that tells us, first off, that tells us that it's a rectangle. And then how do we decide it's a square? The sides are congruent. It's a parallelogram. So opposite sides are congruent. So that's congruent to that, that's congruent to that, and we know it's a square. And I just said, because we know we have four right angles, what else does that tell us it is? A rectangle. If it's a square, it is also a rhombus, yes, because all four sides are the same. It's a parallelogram with all four sides, so it is also a rhombus. So this shape, from knowing that two sides are congruent, one angle is 90 degrees, and it's a parallelogram, we're able to figure out it's a square, a rectangle, and a rhombus. So this shape is all of those things. All right, let's look at another example. So we're going to say that this shape is a rhombus. And again, we want to go by what the problem tells us, not necessarily by how it looks. And we want to find the numbered angles. We want to figure out what those numbered angles are. So we know this is a rhombus. So which one can we figure out really easily? Angle 1 is going to be what? 1 has to be 100 degrees because a rhombus is a parallelogram and opposite angles are congruent. Now how are we going to figure out 2 and 3? The diagonal bisects it, so it cuts these two in half. What do these two have to be together? These are consecutive angles, so this whole thing, so those two together have to be 80. So 2 plus 3 has to be 80. And we know that this cuts them in half, so what does each one have to be? Each one has to be 4. So we know that these two are supplementary, the entire angle, so this entire angle has to be 80. And we know that 2 and 3 are the same, they're cut in half, so each one has to be 40.
Yeah, wait, I'm confused on how.
The whole angle, that whole red angle, has to be 80 degrees. Because this is a parallelogram, a rhombus is a parallelogram. Consecutive angles are supplementary, they have to add up to 180. So together, these two add up to 80. Each one, they're cut in half, so each one is half of 80. Okay? All right, let's look at one last example. So here's our picture for this one. And we're going to say this is a rectangle. And I'm going to draw these in like so, and I'm going to label the sides. Label the vertices. So this is M, N, O, P. So this is a rectangle. We know that PN is 7x minus 8. And MO is 4x plus 10. We want to find PM. So here's PN, and here is NO. What parts of the rectangle are those two? What we call a segment that goes from corner to corner. If it was a rhombus, it would be angle bisectors. What's the more general name? The diagonal. The diagonal goes from corner to corner. What do we know about the diagonals of rectangles? They're congruent. The diagonals are congruent, so how can we write that as an equation? PN is one diagonal, MO is another diagonal. If they're congruent, they're equal. So we say that PN equals MO, or 7x minus 8 equals 4x plus 10. Now we're set. Now we're down to finding x. Subtract 4x. 3x minus 8 equals 10. Add 8. So 3x equals 18. Divide by 3. And x equals 6. And we're done, right? No? Problem asks us to find Pn. So Pn equals 7 times 6 minus 8, which is 42 minus 8. So Pn turns out to be 34. And if Pn is 34, what is MO? Also has to be 34. They're both the same. They're both diagonals. The diagonals of our rectangle are congruent. Questions on that one? All right. We'll put your homework up here, and then we'll talk about last night's homework. So we're doing, we did 2 sections, so we get homework from 2 different pages. All right, there we go.